have an additional example for the ambiguous case. And in this case, we're given that A equals 6, B equals 8, and capital A equals 35 degrees. So there's my capital A, my angle, 35 degrees, and its opposite side is given as 6. I've got an angle B somewhere. It honestly doesn't matter where you put angle B, and angle C in either location, makes no difference. But you do have to make sure that wherever it is that you label angle B, that the side across from that is given as 8. So again, this is a case of an angle, a side, and a side. And that's what gives us that ambiguous case triangle. Alright, so our first step is going to be to solve for an angle using our law of sines. And since we're solving for an angle, it's going to need to have an inverse sign when we solve. Alright, so let's set up our law of sines equation. I'm going to solve for angle B. So the sine of an unknown angle B over its opposite side 8 has to equal the ratio between the sine of 35 degrees and its opposite side 6. So I left C out of it for now because at the moment I don't have any information about C. Alright, so we're going to solve for the angle by cross multiplying. 6 times the sine of B equals 8 times the sine of 35 degrees. Now remember what it is that we're trying to isolate. We're trying to isolate the sine of B so that ultimately we can solve for B itself. And so we need to divide. And so I divide both sides by 6. And remember that in order to undo a sine, I need to inverse sine. So that gives me B, the angle B, all by itself. And if we actually calculate the inverse sine, let me show you on my calculator what that's going to look like. Inverse sine of 8 divided by, 8 times the sine of 35 degrees divided by 6. And that gives me an angle of 49.9 degrees. Okay, so again, this is the ambiguous case. So there are a couple different scenarios. We could get no triangle, and that happened up here when we had a domain error in solving for that first angle. We could also get 2 triangles, or we could get 1 triangle. So our first step is to get 1 angle. And our second step is to test for a second triangle. Let's see if we have a second triangle. If we have a second triangle, then in one scenario, our angle B could be 49.9 degrees. But because of the nature of how the triangle is built, that could also be an obtuse angle that is 180 degrees minus that 49.9 degrees. So we're going to find the alternate angle possibility by always taking 180 and subtracting the angle that you find. So we have B1 as 49.9 degrees, or another triangle could be that same angle having an obtuse measure of 130 degrees. So in order to check to see if this second triangle actually exists, what you'll want to do is you'll want to solve for all the angles in each triangle. Alright, so in one scenario, we've got a 35-degree angle at angle A, and we've got a 49.9 degree angle at angle B. In another scenario, we've got 35 and 130.1. So you'll notice neither of these is necessarily drawn to scale. In this case, I'd have an acute angle, and in this case, I'd have an obtuse angle. So they would create two different triangles if it were possible. So let's see if we can solve for that third angle. If in each scenario we're able to find that third angle, then that means that there are two triangles here that are both possibilities under the given conditions. So I'm going to use the angle sum theorem, and I'm going to solve for the missing angle in each case. And in this one, the acute angle for angle B, my third angle is 95.1 degrees. And in the other scenario, I get a third angle of 14.9 degrees. So because of the fact that we had two possible answers for the first angle that we solved for, and each of those two possible angles creates possibilities for two different triangles, then I can conclude that there are in fact two different triangles that I can solve for here. So when I'm solving, I've got two triangles. That I need to give answers for both. Okay? And so I need to give a B1 as well as a B2, and I need to give a C1 and a C2. So those are the angle possibilities here for B and for C. And then also in this problem I needed to solve for lowercase c, the side length, and I'll have two different options once again. So we already have all the angles for the problem. I had a 49.9 degree angle, and its supplementary angle, 180 minus that, is 130.1 degrees. We already solved using the triangle sum theorem for the other angles in each one of those triangles. And so the only thing left to do now is to calculate the remaining sides. Or in this case, the remaining one side for each of the triangle scenarios. So once again, I'm going to use law of sines in order to do that. This time though, I don't need to use the inverse because I'm solving for a side and not an angle. Okay, so remember we're solving for side C. Let's analyze how I set things up. So I used one ratio that was known, a 35 degree angle, and its opposite side 6. So the sine of 35 degrees over 6. And then remember I'm solving for C, so I need to use its opposite angle in my equation. And the angles for C were either 95.1 or 14.9. And either one is an option, so that means I need to find both side lengths for C under each of those circumstances. So here we'll cross multiply and we'll divide, and that will give us 6 times the sine of 95.1 degrees divided by the sine of 35. So that will give us one possible solution for C, and that is 10.41. And that one's not in degrees because it's a side length, not an angle. Alright, let's find the other possible side length for C, given the other triangle circumstances. So here I'll have the sine of 35 over 6 equals the sine of 14.9 over C. So now I'm using the other possible angle. Once again, cross multiply and solve. You may want to do this on your own now by pausing and seeing if you can get the correct answer. But I have it here, 2.69. Okay, so this is the hardest ambiguous triangle case. There are lots of things you need to look for. First of all, you need to recognize that it's the ambiguous case based on the given information. Then you have to test to see if there's going to be just one triangle that works or two triangles. And again, you know it works if there's room left over for you to find a third angle. In a second, we'll do an example where we try to test for that second triangle, but we end up with a negative number for an angle, which doesn't make any sense. So in this case, they both provided two sensible angle measurements, and therefore we needed to solve not just for 3 different missing parts, but for 6 because of the ambiguity of this particular triangle case.